Recording in progress.
Hello guys, let's have a look at this question. So the question pertains to the topic of kinematics, which is under APC mechanics. So let's read the question. So at time t equal to t1, an object's velocity v1 is shown below. We notice that the velocity is a vector, hence the direction. The direction appears to be towards the right. Now, there is another time t2 at which the velocity has now changed to a different value in terms of magnitude, v2, and also in terms of direction, as shown here. Now, if v2 is equal to v1, now we understand that the velocity are in fact having equal magnitudes, but only different directions. Which one of the following vectors best illustrates the object's average acceleration between t1 and t2? So to understand this, let's first write down the formula for acceleration. We know that acceleration A is given by the formula delta V vector divided by delta T. So remember, acceleration is also a vector. So the formula here becomes vector V2 minus vector V1 divided by T2 minus T1. Now, this being the case, we understand that acceleration A's magnitude can be found out by physical substitution in the given formulas, but the direction of the acceleration will have to be found out through vector subtraction. So let's draw a vector diagram to illustrate the same. So this is V1. Now let's assume that this is V2. Now, if this is vector V1 and this is vector V2, I will just complete the parallelogram. I'm drawing this from the parallelogram law of vector addition and subtraction. Now, in this case, the addition of the two vectors v1 and v2 would be shown exactly like this. The diagonal, which connects the tip of v1 and the tip of v2 as such. But here, since we are actually calculating the difference, that is v2 minus v1, v2 minus v1 is shown by this vector. Remember, this vector shows me the addition, that is v1 plus v2, whereas this vector shows me the subtraction, vector v2 minus vector v1. Hence, I know that option C is the right answer for this particular question. Thank you.